Hello everyone, welcome back to my YouTube channel. In this video, I want to continue to solve past paper from EJU Mathematics Year 2018, second session, course 1, question from section 3. So basically this is the fifth question from this past paper. If you want to watch the solution from the other number from this past paper, you can check link on the description box below. Or you can also check my EJU playlist if you want to watch the solution from the other past paper for your EJU preparation. Before I start, don't forget to hit the like button, share, and subscribe my YouTube channel if you like this video. Let's start to solve this question. In this question, they ask to find the prime factorization of 1400. So we need to find the prime factorization of 1400. So basically, I can write 1400 into 7 times 200 and then 2 times 100 and then 2 times 50, 2 times 25, and then the last one is 5 times 5. So from this multiplication, you can see that 1400 is equals to 7 times 2 to the power of 3 times 5 to the power of 2. So the prime factorization of 1400 is 2 to the power of 3 times 5 to the power of 2 times 7. So from this answer, you already know A, B, C, D, and A, B, C, D, and E. Yeah? So A is equals to 2, B is equals to 3, C is equals to 5, and D is equals to 2. Last but not least, E is equals to 7. And then the number of the divisor of 1400 is blah blah blah. I think to answer this question, you need to know the way or the formula to find the number of divisor of a number after you express that number into its prime factorization. So, if you have a prime factorization of a number, let's say a to the power of n times b to the power of m times c to the power of O, let's say, then the number of divisor of that number, let's say this prime factorization is a prime factorization for A, then the number of divisor of A, number of divisor of A is n plus 1 times m plus 1 times O plus 1. So you just need to see the power of each prime factorization's form. N plus 1 times m plus 1 times O plus 1 and so on if you have another prime factorization. So to find the number of the divisor of 1400, since we already expressed 1400 into its prime factorization, that means the number of divisor is 3 plus 1 times 2 plus 1 times 1 plus 1. So my answer is 3 plus 1 times 2 plus 1 times 1 plus 1. 4 times 3 times 2. My final answer is 12 for F and G. And then the third question, let A and B be any two divisors of 1400 satisfying 1 less than A less than B. There are how many pairs of A and B such that A and B are relatively prime? You need to know the definition of relatively prime. and AB equals to 1400. Relatively prime means the common factor of both number is 1. So there is only one common vector of both number, which is 1. For example, if I have 2 and 3, we can say that 2 and 3 are relatively prime because 2 is 1 times 2 while 3 is 1 times 3. Their common vector is 1. So 2 and 3 are relatively prime. I will give you another example. Let's say I have 2 and let's say 49. The vector of 2 is 1 and 2. The vector of 49 is 1 times 49 or 7 times 7. That means 2 and 49 are relatively prime because their common vector is equals to 1. So the number do not need to be a prime number, but the common vector of those two numbers must equals to 1. That's the definition of relatively prime. So if I want to find how many pairs A and B such that A and B are relatively prime, I can start from the prime vectorization of 1400, which is, if I write down once again, 1400 is equals to 2 to the power of 3 times 5 to the power of 2 times 7. As you can see here, 2 power 3 is equals to 8, and then 5 square times 7, 25 times 7, you will get 175. This is the pair of relatively prime numbers. Because the vector of 8 is 1, 2, 4, and 8, you can find the vector of 8 from this. You have 1, 2, 4, and 8. The vector of 175 is the multiplication of 5 to the power of 2 and 7. So in 175, you do not have vector of 2, 4, and 8. So its common vector is only 1. So how many pairs of A and B that A and B are relatively prime? My answer is 3. Because the first one is 8 and 175. This is the first one, 8 and 175. And then the second one is 25 and 56. 25 and 56. 8 times 7, yeah? You can imagine by using the same illustration that I already gave you earlier. The vector of 25 is only 1, 5, and 25, while the vector of 56 is 2, and then you have 4, you have 8, you have 7, and 56. So its common vector is 1. The last pairs of A and B that are relatively prime is 7 and 200. 8 times 25, yeah? 7 and 200. So we only have 3 pairs of A and B such that A and B are relatively prime. And then among these 3 pair of relatively prime number, B minus A is maximized R blah blah blah. This is B because B greater than A, and then this is A. So all the number here is B, and then all the number here is A. From these three pairs, you can deduce that B minus A is maximized when B is equals to 200 and A is equals to 7. So my answer is 7 here, 200 for J, K, and L. This is B, and then this is A. Next, last question, number 4. For A equals to I, for A equals to 7 and B equals to 200, consider the equation Bx. So I have 200x minus AY, 7y is equals to 1. We can transform this equation into the following equation. If you see the form of this equation, that means we need to isolate y, or we need to express y in terms of x. So I will move 7y to the other side and 1 to the left hand side. Then I will get 200x minus minus 1 equals to 7y. That means I got 200x minus 1 over 7 is equals to y. We need to simplify or manipulate this equation so that we will obtain the equation like this. How to manipulate it? I think I can write down like this. We need to find the greatest number which is less than 200 that is divisible by 7. I repeat it once again. I need to find the greatest number less than 200 that is divisible by 7. And the number is 28, because 28, wait a second, 196 because 196 is divisible by 7. So I can manipulate the equation into 196x plus 4x minus 1 over 7 equals to y. Then I can separate the fraction. So I will obtain 196x over 7 plus 4x minus 1 over 7. 196 divided by 7 is 28. X plus 4x minus 1 over 7. So Mn here is 2 and 8. O is 4. P is 1. And Q is 7. Last question, therefore, among the pairs of positive integers x and y, so x and y are positive integers, that are satisfy equation 1, this is equation 1, or you can say this is equation 1, if we transform it, the pair such that x is minimized is blah blah blah. We need to find the pair such that x is minimized. The point is, or the keyword is, x and y are positive integers. That means for x minus 1 here must be multiple of 7. Because if for x minus 1 here is not multiple of 7, then y will not an integer. So for x minus 1 must be multiple of 7, and then since x is minimized, that means for x minus 1 must be equals to 7, because x is minimized. If I solve this, I will get x equals to 2. Yeah, of course, this is an integer. After I got x equals to 2, I can find y. 28 times 2, substitute it into this equation, or you can substitute it into this equation as well. You choose it by yourself. If I substitute it into this equation, then I will obtain 28 times 2 plus 4 times 2 minus 1 over 7. 28 times 2 is 56 plus 1. My final answer for S and T is 5 and 7. This is the end of this video. I hope you can understand my explanation, and I hope I will see you guys on my next video. Thank you and bye bye.